Let's be honest, the whole AGI debate is a total mess, right? It's getting louder, more chaotic, and frankly, more confusing every single day. So today, we're going to dig into a new framework from a company called AUGNEX AI that promises to bring some much-needed engineering clarity to all that chaos.
The conversation around AGI just feels chaotic, doesn't it? Is it already here? Is it going to be dangerous? Well, according to AUGNEX AI, this isn't just about different opinions. The whole reason the debate is so confusing is because we're all busy asking the wrong questions.
All right, so let's dive into that state of confusion. Right now, the AGI debate is just this tangled mess of conflicting definitions and constantly moving goalposts. It makes having a real, productive conversation almost impossible.
And this is the big one, isn't it? Is AI already here? You see it in the headlines, you hear so-called experts arguing back and forth, and the answer seems to flip-flop every other week. This is the question that's driving all the speculation and, yeah, all the confusion.
And look, this right here, this is a perfect example of the problem. Even the absolute top AI labs on the planet can't agree on what AGI even is. OpenAI is looking at it through the lens of economic value, while DeepMind has this whole framework of performance levels. It's like they're not even speaking the same language.
Okay, so to cut through all that noise, the AUGNEX framework says we need a total reframe. It argues that if we want to actually understand the path to AGI, we have to start by understanding the real job of today's most powerful AI models.
And here it is, the big idea from AUGNEX. These mind-blowing frontier models. They aren't AGI. They're something else. They're a specific kind of tool the framework calls a metamodel. So don't think of it as the AGI itself, but more like a foundational building block for something much, much bigger.
So what exactly is a metamodel? Well, it's an AI that does more than just answer your questions. Its main job is to actually produce or improve other parts of a system. It's literally a model that builds other models, or a model that builds pieces of a system.
And this idea gets really cool when you break it down into the three big things it does. First, it's a universal compiler. It takes our messy human ideas and turns them into clean, structured code and plans. Second, it's a teacher, training up smaller, more efficient student models for very specific jobs. And third, it's a meta-evaluator, which is a fancy way of saying it gets really creative trying to break the system to find its weaknesses. But here's the catch. Even with all these amazing capabilities, there's still this massive gap between what a metamodel can do and what you'd actually need for real, dependable AGI. The framework points out four critical missing pieces.
First up, a serious lack of robust autonomy. The ability to chase a goal over the long term and fix its own mistakes. That's not something a model just has. It has to be engineered into the system that's built around the model. In other words, autonomy isn't a property of the model. It's a property of the whole system.
Second, there's this problem called state fidelity. A model doesn't know what's real. It has no connection to a single source of truth. It just makes its best guess based on the data you give it. And hey, that's fine if you're writing a poem, but it is fundamentally unsafe for anything that actually changes the state of the world, like, say, a bank transaction.
Third, and this is a big one for anyone who cares about safety, they lack sound verification. A model's guess is just that. A guess based on probability. It can sound super confident, super persuasive, but it can never be a truly sound verifier. For something to be safe, you need a separate system that is deterministic and follows the rules 100% of the time.
And finally, their performance is, well, it's all over the place. We've all seen this, right? It's what people call jagged intelligence. The model can be absolutely superhuman at writing some complex algorithm, but then it fails at a really basic logic puzzle. That kind of unreliability makes it incredibly dangerous to give the model the final say on anything important.
Okay, so if the model on its own has all these gaps, how in the world do we fix it? Well, this is where the framework introduces the solution, an engineered architecture it calls the Cognition Operating System.
The Cognition Operating System, or COS, is basically this governing layer that wraps around the model. Its entire job is to take the powerful but kind of wild and unreliable outputs from that metamodel and turn them into safe, reliable, and auditable actions.
And the whole relationship boils down to this really simple but honestly brilliant idea. The model proposes, the COS disposes. The model can come up with a suggestion, but it's the operating system that has the final authority to check it against the rules and decide if it's allowed to happen.
So let's just make this crystal clear. You've got this perfect division of labor. The frontier model, it's the compiler and the teacher. It proposes actions.
But the Cognition OS, that's the authority. It disposes of that proposal, either granting permission and committing the action or rejecting it. That separation is everything when it comes to safety.
And this is where this whole framework becomes more than just an engineering blueprint. It doesn't just give developers a plan, it gives all of us a much clearer way to actually talk about AGI.
You see, AUGNEX says most of the arguments we're having about AGI fall on two different axes. There's the definition axis, that's the fight over what AGI even means, economic value versus performance levels. But the one that really matters is the boundary axis. Are we evaluating the model by itself or the entire system it lives in? And here it is. This is the synthesis that just cuts right through all that noise. The framework says very clearly that AGI is a property of a system, not a model. And once you make that mental shift, the whole debate just, clarifies. We can stop arguing about whether a model is some kind of magic and start asking a way better question. Is the system reliable?
So, what does this all mean for us? Well, it gives us a whole new, much sharper way to talk about this stuff. We should be saying that frontier models are the compiler and teacher layer. We need to be clear that the real reliability and safety comes from the COS layer. And maybe most importantly, we should focus on building AGI-grade system properties and stop just chasing this fuzzy AGI label.
And that leaves us with one last and maybe the most important question of all. If AGI isn't some magical thing that's just going to emerge from a model, but instead it's a complex system that has to be deliberately and very carefully engineered, then who exactly is responsible for building it right?